Hi, this supplementary Algebra 2 lesson covering lesson 78, force vectors at a point. Okay, so what are they asking for? They're going to give us vectors acting at a point, and they're going to say, find the resultant. And we're like, what in the world is resultant? I might have mentioned that before a couple times, but simply when we hear that word resultant, it's another way, okay, we want to add vectors and combine the two vectors into one vector that would represent an addition of these two vectors. And the great thing about forces acting at a singular point, it gives us a point of origin, and we can already set up our reference triangles back to the x-axis. Okay, we have two triangles here. Angle 22 and angle 58, and we have hypotenuse lengths 30 and 40. Okay, so what we're going to do, what do we have to do? We have to break apart the vectors into their right and left components and their up and down components. Okay, I'm going to call this vector number 1 over here. This one is number 2. Okay, let's split apart number 1. Okay, so what do I have? I have an angle of 58 and a hypotenuse of 40. Okay, to find the left and right, the R component, it's the hypotenuse times the cosine of my reference angle, which is 58. I put that in the calculator, I get 21.20. Okay, to get that is to get the R for number 1. To get the up and down component, it's the hypotenuse times the sine of my reference angle, 58. I type that in, I get 33.92. Okay, now I'm going to go to vector 2 here and split that apart. Number 2. Okay, the R component is going to be the hypotenuse length, 30, times the cosine of my reference angle, which is now 22. Okay, that comes out to be 27.82. And then the U component, the up and down, is the hypotenuse length times the sine of my reference angle, 22. That comes out to be 11.23. Okay, so what do I have here for this R? I look back at my triangle. Okay, this is my point of origin for both triangles. What does R do for triangle number 1? It goes to the left. So I have a minus 21.20 R, plus it goes up after that, plus a 33.92 up and down. Okay, for this one, I look at them. I'm going to the right and up. Both components are positive. 11.23 up and down. Okay, I add the R's and I add the U's together. Okay, I get a plus 6.62 R plus a 45.15 U. By the way, this is practice problem on lesson 78, one of your homework problems. I forgot to mention that at the beginning. Sorry about that. So this is my resultant vector in rectangular form. But I don't want it in rectangular form. I want it in polar form. What do I have right now? I have a reference triangle that goes 6.62 to the right and 45 degrees to the left. Or not degrees, 45 units up. 6.62 to the right, 45.15 units up. It gives me this vector right here. Okay, I need to find this angle A. Okay, the angle A is going to be the inverse tangent of the side opposite to it, 45.15. divided by the side adjacent to it, 6.62. Okay, that's going to equal, when I put it in my calculator, 81.66. What is it? It's in degrees. Okay, now I can use, again, the Pythagorean theorem to find this hypotenuse, and basically, and what is the hypotenuse? I'm going to call it R. Why R? It is the resultant. Okay, so really what they're asking for the resultant, they are wanting to know what the hypotenuse is and the angle of that hypotenuse when we add those two vectors together and we get that in rectangular form. What is the hypotenuse of that final added vector? Okay, the resultant. It's the final hypotenuse with that final angle. Okay, I'm going to use my trig function that R, the cosine of my reference angle, 81.66, is equal to the side adjacent, 6.62 over R. Okay, and will I have room to fit that in? Yeah, so that leaves me R will then be equal to 6.62 over the cosine of my reference angle, 81.66. I'm just barely squeezing that in there. Good. And what do I get for an R? I get a 45.64. Okay, that is R. So then I go ahead and I express that resultant, adding vectors. What is the resultant? It's a length of 45.64 at an angle. And is this angle the reference angle, the proper angle I need? Yeah, it's in the first quadrant. Okay, both of these are positive, so this angle is actually the same angle as my graphing angle. Okay, 81.66 degrees. And that is my answer. So this is the fourth lesson now in adding vectors. This is kind of what we wanted to end up at. And by the way, we just got our new geometry books in for next year. And for geometry, where do they end in the year? They end with trig functions adding vectors. So I think we ended the year about right according to what they went over in geometry. So I hope that helps. Here's one of your homework problems, the practice problem for lesson 78. Shoot a text message or an email with any questions, and hey, last lesson of the year, we're done. So you guys did a good job keeping up on your homeworks through this remote learning. Let's hope and pray we never have to do this again. So long for now.